Hey guys, welcome back to Unit 2 and a video on polynomial division. So we're going to talk about some different methods that you can take to deal with problems that involve dividing with variables. So if I take you back to elementary school when we learned how to divide using long division, you would ask yourselves, how many times does 5 go into 21, for example, and come up with the answer. It goes into 21 4 times. And you would multiply that back. 4 times 5 is 20. Then you would draw a line and change the sign. You'd take that away, and that would leave you with a 1. So in this case, 21 divided by 5 does not divide evenly. We do have what's called a remainder, and there's a couple different ways that you could write that. One would be to say that you have 4 remainder 1. Another way that you could say that would be 4 and 1 over 5, since 5 does not go into 1. You can write that as a fraction as well. We're actually going to write our answers here with fractions if we have remainders. That does not always end up being the case. But what you see here is the same principle you can use if you're going to long divide one of your expressions. Now we do have some steps that we will need to take in addition to that, and I have them listed here. The first step to division, and this goes for any method of division that you're going to choose, is to list all invisible terms in standard form. So what do I mean by that? If I take an example here, okay, and specifically the term on the inside in this case, you'll notice that on the outside, 4x plus 4, there's nothing that's, quote, missing. On the inside, however, if we count down our exponents from 3 to 2 to a constant, we're actually missing, in this case, a term. And that term would be 0x with an invisible power of 1. Okay. Now this is going to be more important when we get to synthetic division, but it's still very important here because for long division, and that's what this is called, polynomial long division, it'll help you set up your columns as you're going through the steps for long division. So what are those steps? Very similar to how we asked how many times does 5 go into 21? We're going to ask, how many times does 4x go into 4x cubed? We're going to always be comparing first terms. For long division, we want to compare first terms, and that means we're going to take, for example, 4x cubed over 4x. Now, if I divide this out, 4 over 4 is a 1. And remember our quotient rule, when we have common bases and we're dividing them, we can subtract the exponents. 3 minus 1 is x squared, right? So here's the way that you can double check this to make sure that you have the right start to your answer. X squared times 4x to the first is 4x cubed. But remember, what do we do when we multiply back? We draw a line and change the sign. Now, we're not quite done multiplying back just yet, because remember, just as 4 remainder 1 times 5 has to equal 21, this times this whole part on the side has to multiply back to give our original problem. If I change this up a little bit and said 20 divided by 5, what would that be? How many times does 5 go into 20? You would say 4. Why? Because 4 times 5 is 20. Likewise, everything up top times everything on the side had better equal everything underneath. So we need to multiply x squared, not just times 4x, but x squared times 4 as well. And x squared times 4 is 4x squared. But remember, what do? When we multiplied 4 back into 5, we drew a line and changed the sign. So in this case, we got positive numbers, but we're taking those away. Those are going to become negatives, right? Just like we subtracted 20 from 21, we're going to be subtracting 4x cubed from 4x cubed. That will cancel out. X squared times 4 is 4x squared. That leaves us with 20x squared. Everything else drops. So we get plus 0x minus 20. and repeat the process. Once again, compare first terms. In this case, that's 20x squared divided by 4x, again, is your first term. And what does that equal? Well, 20 divided by 4 is a 5, positive. We're not dealing with any negatives. And x squared over x to the first, 2 minus 1, is x to the first again, or you can just write 5x as well. How do we double check this? Once again, take this number that you just found, this term, 5x, and multiply it back to everything on the side. Remember, this top part has to multiply back out to this side, this divisor, to equal what you have underneath. So 5x times 4x, 20x squared. 5 times 4 is 20. X times x is x squared. And 5x times 4 is 20x. 5 times 4 is 20, and the x carries down. But we need to do what? Draw our line and change the sign. So both of these once again will become negative. We're taking them away. You should see once again that this will cancel out, equal 0. 0x minus 20x, and notice now, our columns are lined up. If we did not include that 0x, our columns would not line up, and that will be a problem. So 0x minus 20x is negative 20x. Again, this has not been worked with just yet. Repeat the process. Once again, compare first terms. Negative 20x divided by 4x. Okay. Negative 20 over 4 is negative 5. And in this case, x divided by x is 1. Cancels out. 1 times anything stays the same. So to double check that this, once again, multiplies out evenly, and sometimes it doesn't, sometimes we have a remainder, but in this case, a negative times a positive will be a negative 20x, right? Negative 5 times 4x is negative 20x, and negative 5 times 4 is negative 20. But we need to draw a line and change the sign, and that changes everything here, in this case to positive, and in this case we have no remainder, right? Opposites cancel out. And if you double check this by multiplying it out using the box method, for example, which we will see shortly, actually, x squared plus 5x minus 5 is your quotient or your answer, because that multiplies back out evenly with 4x plus 4 to give your original problem. Okay, so that would be long division and all of its steps. But there are other methods that you can use to solve polynomial division. So I'm going to do one more example with long division very quickly. Okay. And then we're going to see a different method that you can sometimes use. Okay. And so we have an example here. First step, list all invisible terms in standard form. Well, in this case, everything is visible, so we don't have anything to list out. Notice this was missing a x. That's why we had to put 0x in our original example. Here, though, x minus 1, there's nothing missing there. We had a degree 1 and then a constant. Likewise, x squared plus 5x to the first plus 6, there's nothing missing, right? There's no missing term. 2, 1, 0. So we can go immediately into long division, compare first terms. X squared over x, first term to first term. What is x squared divided by x? Well, that's going to be another x, because x times x is x squared. So we're going to take what we just found, multiply it back to both terms on the outside. X times x we just said was x squared. X times negative 1 is negative 1x. But we draw a line and change the sign. Now in this case we have to change one of these from positive to negative and the other from negative to positive. So when you draw the line, change the sign, some of those signs might be opposite of each other, but that's because they started as opposite, right? This one was negative, this one was positive. That gives you different signs when you draw that line and change the sign. In this case, x squared minus x squared cancels out. 5x plus 1x is 6x, and 6 carries down. We repeat the process. So compare first terms. 6x divided by x, well, x cancels out in this case. You should see that 6 is what we have left over here. Okay. So once again, multiply that back, draw a line, change the sign. 6 times x is 6x. 6 times negative 1 is negative 6. And in this case, we're going to, once again, draw a line, change the sign. That turns into negative 6x. That turns into positive 6. And in this case, you can see that we actually have a remainder. And that, again, sometimes happens. How we deal with that is to take that 12, and notice, we can't divide 12 by x, right? That's not going to change anything. So what we do is we leave that as a fraction. We add 12 over x minus 1. This would be our final answer, including the remainder, or the fraction part of the quotient, is another way to say that, because we can't divide 12 by x minus 1 evenly. So that's long division. We're going to set that aside for now, and try a different method of division for this specific problem. So this is what's called synthetic division. Now, synthetic division can't always be used, okay? There are rules. Synthetic division can only be used if what you're dividing by is linear, so degree 1. You can't divide by x squared with synthetic division. You can do that with long division. If that was 4x squared, that wouldn't be a problem with long division. For synthetic division, make sure that the degree is an invisible 1, and that your lead coefficient is a positive 1. It just makes things more simple. If you can't have that happen, just use long division instead. So why would we want to use synthetic division? Well, because it turns out it's a little bit easier if you get used to the pattern that follows. So the first thing we're going to do is take what we're dividing by. This is step 1 for synthetic division. X minus 1, set that equal to 0, and isolate x. So in this case, x equals 1. Okay, that's the first step to synthetic division. Step 2 is what's called a setup. Okay, we're going to take that 1, put it in a little half box here, and then we're not going to be dealing with variables, and this is the nice thing with synthetic division, until the very end. Instead, what we're going to do is list the coefficients of our terms. In this case, that's going to be invisible 1, a positive 5, and a 6. We're going to set up 3 columns here in this case. Notice we did not have any invisible terms, x squared, x constant. Okay, nothing to have to rewrite, as we mentioned before. If we did have something to write, we would have to have a 0 here. For instance, the synthetic division setup for this problem would look something like 4, 24, 0, and negative 20. Now, we would not use synthetic division for this problem, obviously, because the lead coefficient of our divisor is not 1. Right? We always want to use synthetic division only when we have a linear divisor, degree 1, and the lead coefficient is an invisible 1. Okay, that was not the case up here. But if we did have that, we would always want to list an invisible 0 if we have one for missing terms. Now, we didn't have any missing terms, so now that we've established that, here's what we do next. Okay. We drop the first number, so that stays a 1, and then we take anything below the line, multiply it, in this case, by a 1, to get new column information. In this case, that's a positive 1. Okay. Add up and down. 5 plus 1 is 6. Once again, multiply diagonally. Add up and down. 6 times 1 is 6. Add up and down. 6 plus 6 is 12. And what it turns out to be the case is that this is our remainder for our problem. As we just saw, right? 12 is our remainder. Well, synthetic division confirms that. 12 is going to be our remainder. And we were dividing again by x minus 1. Okay. This 6, the number next to the remainder, is always your constant. Now sometimes it's 0, sometimes it's not. In this case, it's a positive 6. As we saw earlier, it should be, right? And lastly, this 1 underneath the line is our coefficient for x to the first power. And that's what we saw earlier as well. X plus 6 plus 12 over x minus 1. What synthetic division does is to find the coefficients for all the terms in your problem, if you have them. Right now, sometimes they're 0, in which case you can leave them out. But if you do have a coefficient, you do need to list it. And it always goes from your remainder on the far bottom right of the numbers that are underneath the line. Your remainder, your constant, degree 1. If we had another column, it'd be degree 2, like x squared, x cubed, so on and so forth. So that's where synthetic division can be very useful. It just helps you not to have to deal with a lot of different variables. As you can see in this problem here, we had to draw lines and change signs after we divided first terms. And it dealt with a lot of different variables like x cubed, x squared, so on and so forth. Synthetic division, if you get the hang of it, makes the process a little bit easier by just dealing with the numbers. 1, 5, 6, 1, 5, 6. Again, add up and down, multiply diagonally, add up and down, multiply diagonally, add up and down. That establishes what your remainder is, if you have one. In this case we did. And what you have as a constant next to that remainder, what you have as a coefficient of x squared, or other columns that might appear. Hopefully that makes sense. Division is one of the more complex subjects in Algebra 2, so I would recommend that if you do need extra help with this, come and talk to me, and hopefully this does help in some capacity. So I will see you for our next video. We only have 1 or 2 more to do before the unit is done, and your midterm is coming shortly. So